Hello, welcome once again to the ninth video of the second part, which is the intermediate level of my advanced Excel tutorial. On this video, we are going to look at other financial functions, and here I'm going to demonstrate the use of three financial functions: PMT, PPMT, and IPMT functions to preparing a loan amortization schedule. This is a real life practical problem which you might face. Now, buyer collected a loan of 700,000 naira from FBN with interest rate of 21% and a tenure of 3 years. Prepare an amortization schedule to show how the loan will be repaid over a period of 3 years. Corporate entities face this kind of problems, and as a finance person or a business person, you should be able to calculate a simple loan amortization schedule to have an idea of your total interest exposure and cash flow exposure for repayment of the loan. So now I have outlined this data here on a worksheet: the loan amount, the interest, and the tenure. Now if you look at 3 years here, you can see it is showing 3 years here. This is custom formatting we have treated on our earlier video. Now this is just 3. What you are seeing here is different from what you are seeing here. Now you are visibly seeing 3 years, but the underlying figure is just 3 here. I only type 3 and not 3 years. The reason why it is like this is because it is formatting. You can actually use this to do calculations. This is custom formatting. You can visit the early videos, last part of my advanced Excel tutorial, which is the first part, the basic level, where I treated basic formatting. Now let's get started with this. Now the first thing I'm going to do, I'll use the PPMT function to calculate the principal portion. When you collect a loan, you pay the principal and interest portion. The money you pay is the interest and the principal portion. So the principal portion of the loan is calculated using the PPMT function. Now look at the parameters, the syntax of this function. The rate is the interest rate, and because the repayment is monthly, so the basis for the interest rate must be the same with the tenor. Even though the tenor is 3 years, the rate is per annum, but the repayment is monthly, so I'm going to divide this rate by 12. And the period, the PER parameter, is the period number, the period index, not the total period, which is the first period. I'm going to leave this. I'm not going to lock the position. I'm going to make it relative so that when I copy the formula, it will refer to other range of cells. Now the NPER is the number of period, which is 3 years. Now the 3 years should be the same base with the repayment, so I'm going to multiply this by 12 because I didn't write 36 months here. I'm going to multiply this by 12 to make the basis of the total repayment period to be the same with the interest. So I multiply by 12. I'm going to also make this absolute reference because I'm referring to a fixed location on the worksheet and I have to copy the formulas down. I'm also going to make this absolute reference because I'm also referring to a fixed location. Then the next parameter is the PV, which is the present value, which is the loan amount. Now I will use a minus sign because my result will give me negative, so I don't want to use the absolute reference, the absolute value function. So now, because it represents repayment, then the future value of a loan is 0. The loan itself is the present value. Then the type is at the end of the year, 0. So when you copy this down, this is the total something. Okay, I need to log the position of this, the principal, the loan itself. So when you copy this down, you have the principal repayment for each period. Now the same goes for the interest repayment. I can copy this and change this to interest portion, IPMT, which is the interest portion. Now here we have B. Okay, because this is actually supposed to refer to this area here, so this is B, not C. This area is B because I copied the formula. I did not lock the position of this area. That's why it changes the relative location. So this one is for the interest portion, which has the same structure with the principal portion. You can see the syntax. It has the same structure. Then I can now copy the formulas down. Then the total repayment, you use the PMT function. The rate is 25% divided by 12, and you log the position of B11. Now also the number of period, you can see the structure. Number of period is 3 years. You log the position, multiply by 12, because the repayment is monthly, so the tenor must also be monthly. Then the present value is the loan. Now I'm going to log the position of this also, but I will use a negative sign because this value will give me negative because of the fact that it is to represent cash outflow, but I don't want to have negative values. Otherwise I would have to use the ABS function. Then the future value of a loan is 0, and the repayment is at the end of the period. So now you can see that the sum of this and this here represent the total repayment. Even though we used we calculated them differently, the total repayment will be constant over a period of time. Now if you want to now show how the loan will be repaid, now how much would you have at the end of the first month is the loan you collected plus the interest added to the loan minus any money you paid. So this is what you have at the end of the first month. How much would you have at the end of the second month is equals to the balance at the end of the first month plus any additional interest minus repayment. So you can now copy this down and you will see how the loan is completely repaid. So this is how to use the three financial functions to calculate a loan amortization schedule. So we have come to the end of this video, finance functions. On our next